There are 5 charges plus q each placed at the 5 corners of a regular hexagon of side A. We have to find the magnitude of the force experienced by a charge minus q placed at the center of the hexagon. Now before solving this problem, we will attempt a similar problem in which 3 charges are placed. Let us draw it here. 3 charges are placed at the 3 corners of an equilateral triangle. 3 charges, each of plus q each. So plus q each are placed at the 3 corners of an equilateral triangle ABC. Let us assume that the side is A. Then we have to find the net force experienced by a charge plus q placed at the center. So let us call this point as O. We must find the force magnitude of the net force experienced by the charge plus q placed at the center of the triangle. Now in order to find this, we will use Coulomb's law, and by looking at the diagram and the geometry of the situation, we can see that the magnitude of the forces due to force experienced by the charge plus q at O due to all the other charges are equal. The magnitudes are equal because the charges are equal and the distance from the corresponding points are also equal. So the magnitudes are equal. Now we also know that electrostatic force is a central force. Therefore, if you look at the force experienced by the charge plus q at O due to the charge plus q at A, we can see that it is directed along the line AO. The direction is along this line. Its direction is along AO. It's a repulsive force. Therefore, it is directed along AO. Similarly, the force on the charge q at O due to the charge q at B will be directed along BO, and this is its direction. And finally, the direction of the force on the same charge due to the charge plus q at C will be directed along CO. Now this is the direction. Now you see that all these, as we have seen a little earlier, all the forces are of equal magnitude. Still we will name them as, let us call this as F1. Let us name this as F1, this one as F2, and this one as F3. And we know that mod F1 equal to mod F2 equal to mod F3. Now look at F1 and F2. They are acting at 120 degree between them. So this angle is 120 degree. Now what is the magnitude of the resultant of two forces of equal magnitude, or rather two vectors of equal magnitude acting at 120 degree? So if F and F acting at 120 degree, if and F are acting at 120 degree, then the magnitude of the resultant is also F. So these two, F1 and F2, have a magnitude which is equal to F, because mod F1 equal to mod F2. Let us call this as F. Then the resultant of these two forces, F1 and F2, acting at 120 degree has a magnitude F, and that is acting at 60 degree with either vector. Resultant will be along the bisector. Now you look at F3. F3 has the same magnitude as of F1 and F2, and it is acting opposite to the direction which the F is acting. Therefore, the resultant of F and F3 will be 0, which means that the net force experienced by the charge at O is 0. You can extend this to other geometries or other cases also, in which charges are placed at the corners of figures having different geometric shapes. So now let us inspect the situation here. We have 5 charges which are placed at the 5 corners of a regular hexagon. Now if we had a charge plus q here, then the net force experienced by the charge minus q at O would have been 0. Because we can extend the similar treatment here. If you extend the treatment that we had seen here to this situation, we will find that the net force experienced by the charge minus q at O would have been 0 had there been a charge plus q here, and we don't have a charge plus q there right now, which means that the magnitude of the force due to all the other charges, the sum of all the forces due to other charges experienced by minus q at O, let us call it as F1, plus the force due to the charge plus q placed at D will give you 0, which means that F2 equal to minus F1 or mod F2 equal to mod F1. And what is mod F1? What is mod F2? Because F2 is the force due to the charge plus q, which is not right there now, but we assume that a charge is there. Then what is the magnitude of the force due to the charge plus q here, assumed to be here, experienced by the charge minus q at O? It is 1 by 4 pi epsilon 0 q square by L square. So that would have been that is the sum of the magnitude of the sum of the forces due to all the other charges placed at the 5 corners of the regular hexagon.